November 26, 1943, 50 miles northwest of Tarawa. The Pacific night hung absolute and black. Lieutenant Commander Edward Butch O'Hare gripped the controls of his F6F Hellcat as it climbed through darkness so complete he could see nothing beyond his instrument panel's faint red glow. No moon, no stars. Heavy cloud cover sealed the sky like a tomb. His radio crackled with vectors from the USS Enterprise, distant voices guiding him toward 9 Japanese torpedo bombers approaching the task force. O'Hare was leading the U.S. Navy's first carrier-launched night fighter mission, flying toward an enemy he could not see, hunting in conditions where Japanese pilots had owned the night for 2 years. The darkness was their weapon. For centuries, night had belonged to those who dared to use it. But on this November evening in 1943, something fundamental was changing in the physics of warfare. The Americans were bringing technology into the void, radar systems that could see through darkness as if it were day. O'Hare would not return from this mission. His Hellcat would disappear into the Black Pacific, cause uncertain, body never recovered. But his sacrifice would prove that night interception was possible, that the darkness the Japanese had mastered could be penetrated by electronic eyes that never blinked. January 1942. Rabaul. Japanese bomber crews prepared for another night raid on Guadalcanal. They flew G-4M Betty bombers, twin-engine aircraft with exceptional range but minimal protection, machines the Americans called flying lighters for their tendency to ignite when hit. The crews understood the risk, but night offered sanctuary. American fighters operated during daylight. American anti-aircraft fire required visual tracking. American ships depended on lookouts straining to see against the stars. Japanese pilots had trained extensively for night operations, exercises conducted in complete darkness, navigating by compass and dead reckoning, bombing targets they could barely see. The Imperial Japanese Navy had built its entire doctrine around night combat superiority, the ability to strike when the enemy was blind. The confidence was earned through experience. Japanese forces had humiliated American naval units in night surface engagements throughout 1942. The Battle of Savo Island in August had been a catastrophic demonstration of Japanese night fighting superiority. 4 Allied cruisers sunk, over 1,000 sailors dead. American forces scattered in confusion, while Japanese destroyers maneuvered with precision in total darkness, using searchlights and superior training to dominate an engagement. The Americans never understood they were losing until it was over. If the surface fleet could achieve such victories in darkness, the bomber crews reasoned, then night raids offered similar advantages. Americans would hear the engines overhead but see nothing, fire blindly into empty sky, count their dead at dawn. The Americans expected night raids but lacked effective countermeasures. Army Douglas A-20 Havocs painted black and fitted with British radar sets had been sent to Guadalcanal in February 1943, but the aircraft's ceiling was too low to intercept high-flying bombers. P-70s arrived with radar but no ground control to guide them. P-38 Lightnings tried working with searchlights, dangerous coordination that rarely produced results. The Japanese raids continued nightly, small formations dropping bombs on airfields and anchorages, destroying aircraft on the ground, sinking ships at anchor, denying American forces sleep, and eroding morale. The attacks caused limited physical damage but enormous psychological impact. The Marines nicknamed the raiders Washing Machine Charlie for the distinctive unsynchronized engine sound that echoed across Henderson Field each night. The name was darkly humorous. The reality was exhausting terror. Men lying in foxholes listening to bombs whistle down from invisible aircraft, praying the explosions would miss. The Japanese believed darkness was an absolute advantage, that visual limitations applied equally to both sides. They trained to fight blind, to navigate without seeing, to bomb targets by calculation rather than observation. What they failed to comprehend was that the Americans were not trying to fight in the dark. They were trying to eliminate darkness as a factor. In laboratories at MIT and the Naval Research Laboratory, in workshops at Grumman and Northrop, American engineers were building electronic eyes that could see through night as if it did not exist. September 1941. The U.S. Navy issued requirements for carrier-based night fighters equipped with airborne radar. The specification seemed impossible. Carrier aircraft had to be single-engine, light enough to operate from carrier decks. Radar systems in 1941 were massive installations, Heavy equipment that filled entire rooms. Airborne radar for night fighters would require miniaturization that did not exist. Compact systems light enough for fighter aircraft yet powerful enough to detect targets miles away. The British had deployed night fighters with radar in the Battle of Britain. But those were twin-engine aircraft like the Bristol Beaufighter. Large machines operating from land bases with radar sets weighing hundreds of pounds. The Navy needed radar that could fit in a single-seat fighter, operating from a moving carrier deck at night. The technological challenge was staggering. President Franklin Roosevelt had recognized the importance of radar early. In 1935, at the urging of Rear Admiral Harold Bowen, Congress appropriated $100,000 for radar development at the Naval Research Laboratory. By April 1937, the Navy had operational radar installed on the destroyer USS Leary. Production models followed on battleships and carriers by 1939. The British Tizard mission in 1940 brought cavity magnetron technology to the United States, revolutionary components that enabled microwave radar with dramatically improved resolution. Roosevelt established the National Defense Research Committee in 1940, reorganized as the Office of Scientific Research and Development in 1941 under Vannevar Bush, with nearly unlimited funding for radar research. The MIT Radiation Laboratory became the center of American radar development, employing thousands of scientists and engineers, producing designs that would transform warfare. The Navy's night fighter program, codenamed Project Affirm, began April 18, 1942, at Quonset Point, Rhode Island. The challenge was not just technical but operational. Night carrier operations were extraordinarily dangerous. Landing on a carrier deck during daylight required skill and nerve. Landing at night on a pitching deck barely visible against the ocean seemed suicidal. Flight deck crews would work in near total darkness, guiding aircraft with dim red lights, risking death from propeller strikes and deck accidents. The pilots would launch into void, navigate by instruments, locate targets with primitive radar, engage enemy aircraft they could barely see, then return to find a carrier showing minimal lights in thousands of square miles of empty ocean. Every aspect of the operation violated standard procedure. But the Japanese owned the night and the Americans needed to take it back. The first airborne radar for Navy fighters was the AN/APS-4, a system housed in a wing-mounted pod. 18 F6F Hellcats were fitted with the APS-4 in 1943. The radar could detect aircraft at 4 miles, barely adequate for interception. The system was upgraded to the AN/APS-6, a more capable radar that became standard equipment for Navy night fighters. The APS-6 used a 17-inch parabolic antenna, transmitting in the X-band at 9,375 MHz. The radar employed a spiral scan pattern, the antenna rotating rapidly to sweep a cone-shaped volume of sky ahead of the aircraft. Maximum theoretical range was 60 nautical miles, though in practice air targets were detected between 5 and 8 miles depending on size and altitude. The display showed targets as blips on a scope, with a unique double dot system that indicated target altitude relative to the fighter. One dot represented the target's actual position. A second ghost dot appeared to the right, its vertical displacement showing whether the target was above or below the interceptor. The innovation was elegant and practical, giving pilots 3-dimensional target information on a 2-dimensional display. The radar operator in P-61 Black Widows sat behind the pilot, studying the SCR-720 display, calling out range and bearing. The SCR-720 was heavier and more capable than the Navy's APS-6, weighing 415 pounds not including cables. The radar could search a full 180 degrees forward of the aircraft, with selectable ranges of 1, 10, 20, or 100 miles. Detection range against fighters was approximately 5 miles, sufficient to guide the Black Widow into firing position. The P-61 relied on this radar entirely, hunting in darkness so complete that visual acquisition was often impossible until the target was within a few hundred yards. The aircraft was painted matte black to reduce visibility. Crew members wore special goggles to preserve night vision. The cockpit lighting was minimal, red instruments that would not ruin the pilot's adaptation to darkness. Everything about the design emphasized operation in conditions where human eyes were useless. March 1944. The first F6F-3N Hellcats equipped with AN/APS-6 radar reached the Pacific Fleet. VFN-76 and VFN-77, the Navy's first dedicated night fighter squadrons, began operations from USS Hornet and USS Yorktown. The squadrons developed tactics that would devastate Japanese night operations. The fundamental innovation was the radar barrel, a cylindrical search pattern where multiple night fighters orbited at different altitudes, their radar cones overlapping to create detection coverage impossible to penetrate undetected. When contact was made, the nearest fighter would accelerate to attack speed, approaching from below and behind where most enemy aircraft had minimal defensive armament. Ground control was essential. Microwave early warning radars on Saipan could detect incoming Japanese formations at 150 miles, and TPS-10 height finder radars nicknamed Lil Abner determined altitude with precision. Fighter directors in makeshift command huts would vector night fighters toward targets, providing constant updates on bearing, distance, and altitude. The system worked because radar removed guesswork. Directors did not estimate enemy position from sound or glimpse. They watched precise plots updated every few seconds, calculated intercept courses mathematically, guided fighters with confidence born from electronic certainty. Japanese pilots had no warning. They flew toward what they thought were blind targets and encountered interceptors positioned with uncanny accuracy, attacking from optimal angles as if they had been waiting there for hours. June 24, 1944. The 6th Night Fighter Squadron arrived on Saipan flying Northrop P-61 Black Widows 9 days after initial Marine landings. 2 P-61s were destroyed in landing accidents the first night, killing their crews, reducing the squadron to 5 operational aircraft. But on June 30th, a P-61 crewed by 2nd Lieutenant Dale Haberman and Flight Officer Raymond Mooney shot down a Mitsubishi G4M Betty bomber in the first confirmed kill by an American night fighter in the Pacific. The Black Widow had proven its capability. The Japanese raids that had terrorized American positions for 2 years were now facing systematic interception by aircraft that could hunt in total darkness. The psychological impact on Japanese bomber crews was catastrophic. They had operated with relative impunity for years, facing occasional searchlights and sporadic anti-aircraft fire, but rarely encountering effective fighter opposition at night. Now they were being intercepted regularly, attacked by aircraft they could not see until tracers revealed their position, shot down in darkness by enemies who seemed to possess supernatural vision. Japanese tactics had relied on darkness for concealment. American radar turned that concealment into illusion. The Betty bombers approached in formation stretched across 20 miles, individual aircraft separated to avoid collisions in the dark. If the lead bomber was shot down, the others would typically jettison their ordnance and flee rather than continue the attack. Between June and January 1945, the 6th Night Fighter Squadron intercepted 27 of 37 raids on Saipan. They claimed only 8 confirmed kills, but the mere act of interception was enough. Japanese commanders recognized their bomber crews were flying into defended airspace where darkness no longer provided protection. The raids became sporadic, then ceased entirely. Japanese night fighter development had failed to keep pace with American innovation. The Japanese military developed 5 types of airborne radar during the war, primarily air-to-surface vessel systems for detecting ships. Airborne interception radar for night fighters was attempted, but never succeeded operationally. The Army copied the German Fuji-202 radar and tested it in a Mitsubishi Ki-21 bomber in 1943, but the system either never reached combat units or made negligible impact. The more advanced E-1 radar operated at 11 centimeter wavelength and was installed in Kawasaki Ki-45 Toryu night fighters. Some aircraft also carried searchlights in the nose, a crude solution that revealed the interceptor's position while attempting to illuminate targets. Even when Japanese night fighters were equipped with radar, operators lacked training and ground control was non-existent. Japanese pilots hunted by moonlight, searching for B-29 contrails against the stars, depending on visual detection in conditions where American radar-equipped fighters operated with electronic precision. The disparity became obvious to Japanese survivors. Captured pilots interrogated after the war described missions where American fighters had appeared from nowhere in total darkness, attacking with accuracy that seemed impossible. One pilot, shot down near Saipan in November 1944, told his interrogators simply, "We believed we came from the night, but the night now belonged to them." The statement captured the psychological reversal. Japanese doctrine had emphasized night operations as a force multiplier, a way to leverage superior training against numerically stronger opponents. American technology had nullified that advantage completely. Darkness that had favored stealth now favored detection. What once concealed attackers now exposed them to radar systems that saw through night as if scanning daylight sky. The Japanese Navy confirmed American radar superiority definitively after the Battle of Cape Esperance on October 11, 1942. That engagement marked the first time Japanese forces lost confidence in night surface combat, the traditional superiority they had relied upon to compensate for inferior air power. The realization that Americans could detect and track ships in total darkness using fire control radar demoralized Japanese destroyer crews who had previously dominated night engagements. Captain Reizo Tanaka, commander of destroyer squadrons that had run the Tokyo Express supply missions to Guadalcanal, wrote in 1956 that while his tactical brilliance had achieved some successes, he recognized that darkness no longer provided protection against American technology. By early 1943, American destroyers were intercepting Japanese forces in complete darkness, in rain, in squall conditions, firing first with radar-directed accuracy and pursuing Japanese forces even when they fled at full speed into the night. The technology gap was not merely quantitative but philosophical. Japanese military doctrine valued training, discipline, courage, attributes developed through rigorous preparation and warrior spirit. Night combat was seen as a test of these qualities, an environment where superior training would overcome material disadvantage. The Americans approached the problem differently. They did not try to train pilots to see in the dark. They built machines that eliminated darkness as a factor. The distinction was fundamental. Japanese pilots trained for hundreds of hours in night flying techniques, developing skills through repetition and experience. American pilots flew with radar operators who guided them to targets using electronic displays, technology that could be taught in weeks rather than years. The Japanese invested in human capability. The Americans invested in technological systems that made human limitations irrelevant. The AN/APS-6 radar that equipped F6F Hellcats became symbolic of this technological advantage. The radar pod mounted under the right wing was unmistakable, a distinctive bulge that Japanese pilots learned to fear. At night, that pod housed electronics that could detect aircraft through clouds, through rain, through darkness so complete that human eyes were useless beyond a few yards. The radar transmitted pulses of radio energy, received echoes from distant targets, displayed those echoes as glowing dots on a screen. The process was repeated thousands of times per second, creating a constantly updated picture of the sky ahead. A pilot equipped with APS-6 could hunt enemy aircraft in conditions where Japanese pilots were effectively blind, approaching undetected because radar detection was one-directional. The American fighter could see the Japanese bomber on radar. The Japanese bomber had no way to detect the American fighter until tracers revealed its position, usually seconds before impact. The P-61 Black Widow represented the ultimate expression of radar-equipped night fighting capability. The aircraft was the first American combat plane designed specifically as a night fighter from the drawing board. The twin-boom configuration, twin Pratt & Whitney R2800 engines producing 2,000 horsepower each, armament of 4 20mm Hispano cannons in the belly, and 450 caliber machine guns in a dorsal turret, all combined to create a formidable weapons platform. But the radar made it revolutionary. The SCR-720 system mounted in the extended nose provided detection and tracking capability that allowed crews to intercept targets in any weather, any lighting condition. Maximum detection range was approximately 5 miles against fighters, 15 miles against large bombers. The radar operator would guide the pilot toward targets, calling out bearings and range, adjusting intercept courses as the enemy maneuvered. When range closed to visual distance, the pilot would take over, using night binoculars that gathered available light to acquire the target, positioning for a firing pass from below and behind. July 3, 1944. A P-61 of the 422nd Night Fighter Squadron in Europe scored its first operational kill. In the Pacific, Black Widows were proving their worth against Japanese night raiders. The 6th and 548th Night Fighter Squadrons eventually shot down multiple Japanese bombers over Saipan, breaking up raids that would have caused significant damage to B-29 bases being constructed for the strategic bombing campaign against Japan. The mere presence of radar-equipped night fighters altered Japanese tactics. Raids that had been routine became high-risk missions. Bomber crews who had operated with relative impunity now faced interception by aircraft that could find them in any conditions. The psychological pressure was immense. Flying at night in a Betty bomber, knowing that somewhere in the darkness an American night fighter might be tracking you on radar, preparing an attack from an angle you could not see, was terror that no amount of training could overcome. The transformation of American night fighting capability from non-existent to dominant occurred in less than 3 years. In 1942, Japanese bombers raided Guadalcanal nightly with minimal risk. By 1945, American night fighters controlled the nocturnal sky so completely that Japanese commanders abandoned night operations entirely in most areas. The change was driven by radar technology developed under enormous time pressure, fielded in aircraft designed to accommodate systems that barely existed when development began. Project Affirm, the Navy's crash program to develop carrier-based night fighters, succeeded through combination of MIT radiation laboratory innovation, Grumman's engineering expertise, and operational necessity that permitted no failure. The alternative was continued Japanese dominance of night operations, raids that would destroy aircraft and ships and men with impunity, because darkness rendered American defenses useless. The radar itself was testament to American industrial and scientific mobilization. The AN/APS-6 used cavity magnetron, technology that Britain had shared with the United States in 1940. The magnetron produced microwave radio waves with power and precision, impossible using previous methods. American engineers miniaturized the technology, reducing systems that filled rooms to units that weighed 242 pounds and could be mounted in fighter aircraft. The development required innovations in electronics and display systems, in power supplies, and antenna design. Each component pushed technological boundaries. The complete system worked because hundreds of engineers solved thousands of individual problems, coordinated through research institutions funded with resources that Japanese scientists could never access. The Japanese faced constraints that made radar development nearly impossible. Raw materials were scarce. Electronics manufacturing capability was limited. Research facilities lacked equipment and expertise. Inter-service rivalry prevented Army and Navy from coordinating radar research, leading to duplicated effort and incompatible systems. Even when Japanese engineers developed prototype radar systems, manufacturing capacity could not produce them in meaningful quantities. The few Japanese aircraft equipped with airborne radar operated without ground control networks, without trained operators, without tactical doctrine for radar-guided interception. They were experimental systems fielded in desperation, too late and too primitive to affect outcomes. The Americans fielded 791 AN/APS-6 radar sets between April 1944 and April 1945 alone. 791 complete airborne radar systems, each one representing manufacturing capability and technological sophistication that Japanese industry could not duplicate. The P-61 Black Widow, a specialized night fighter designed and built for a single purpose, entered service in numbers that exceeded all Japanese night fighter production combined. Approximately 700 Black Widows were manufactured. The Japanese converted existing aircraft types for night fighting, adding radar and oblique firing cannons to reconnaissance planes and bombers never designed for the role. The modifications were improvised solutions to capability gaps that widened every month. American purpose-built night fighters dominated skies where Japanese converted aircraft struggled to participate. August 14, 1945. The last night of the war. A P-61B of the 548th Night Fighter Squadron named Lady in the Dark was unofficially credited with the last Allied air victory before VJ Day, shooting down a Japanese aircraft in darkness hours before the surrender took effect. The symmetry was poetic. The war that had begun with Japanese surprise attacks would end with an American radar-guided kill in total darkness. Technological supremacy eliminating the night advantage that Japanese forces had relied upon throughout the conflict. The radar remained invisible to human senses, but its effects were overwhelming. Radio waves transmitted from American fighters swept through darkness, bounced off enemy aircraft, returned to receivers that processed echoes and displayed targets on glowing screens. The Japanese pilots never saw the radar beams. They felt no indication they were being tracked. The first evidence of American presence was usually tracers passing their canopy. Shells fired from optimal range and angle by pilots guided to perfect firing position through electronic vision. The experience was psychologically devastating, being hunted by an enemy who could see you when you were blind, attacked from darkness by aircraft guided with precision that seemed supernatural. Japanese night combat doctrine emphasized simplicity, maintenance of direction, control, and surprise. Direction was maintained by compass, by guides, by choosing unmistakable features to march toward, sometimes by fifth columnists who lit bonfires as navigation beacons. Control was maintained by selecting objectives on well-defined terrain features. Surprise was achieved through stealth and silent movement. These principles worked in jungle warfare, where both sides operated with similar limitations. They failed completely against radar-equipped forces who did not need visual references, who tracked targets mathematically, who coordinated through radio networks that provided information Japanese commanders could not access. The night that Japanese training had mastered was not the same night that American radar illuminated. Japanese pilots navigated through darkness. American pilots navigated through electronic representations of physical space, representations updated thousands of times per second, more accurate than human vision even in daylight. The AN APS-6 became the symbolic object representing this technological revolution. The radar pod mounted on F6F Hellcats was physically small, 17 inches across, weighing less than 250 pounds with associated equipment. But it represented American industrial capacity, scientific research, coordination between military services and civilian institutions, resource allocation that permitted unlimited funding for critical technologies. The Japanese saw the radar pod and recognized it as evidence of capabilities they could not match. Each radar-equipped fighter represented not just one aircraft, but entire industrial and scientific infrastructure required to produce the technology, train the operators, develop the tactics, coordinate the operations. The pod was visible manifestation of American material superiority, small component that symbolized vast systemic advantages. The terror Japanese bomber crews experienced when radar-guided American fighters appeared from total darkness was rational fear born from technological disadvantage. They were being hunted by machines that could see through night, track targets through clouds, guide interceptors with precision impossible using human senses alone. The darkness that had protected them, the concealment they had relied upon, was irrelevant against radar that detected aircraft regardless of lighting conditions. They could not evade what they could not detect. They could not fight what they could not see. They could only flee, jettison their bombs, and hope to escape before tracers revealed an American fighter positioned perfectly behind them, waiting for optimal range before opening fire. The Americans had not merely developed better night fighters. They had eliminated night as a tactical factor. Darkness still existed physically, still prevented visual observation, still complicated navigation and landing operations. But radar made darkness irrelevant to interception. American fighters hunted as effectively at midnight as at noon, guided by electronics that did not require light. Japanese pilots trained for night operations discovered their training was obsolete. That skills developed through years of practice meant nothing against technology that substituted electronic precision for human capability. The lesson extended beyond night fighting to fundamental questions about warfare in the industrial age. Technology could overcome training. Material superiority could nullify tactical brilliance. Resources properly applied could create capabilities that determination and courage could not match. The Japanese had emphasized warrior spirit, believed that morale and dedication would compensate for industrial disadvantage. They discovered that radar-guided fighters shot down dedicated pilots as easily as fearful ones. That spiritual strength provided no defense against electronic detection. That dying bravely in the dark did not accomplish missions when American technology prevented them from reaching targets. The cost of American radar development was measured in billions of dollars. Thousands of engineers, years of research conducted while the outcome of the war remained uncertain. The Office of Scientific Research and Development, the MIT Radiation Laboratory, the Naval Research Laboratory, private contractors like Western Electric and General Electric all worked with unprecedented coordination and unlimited funding to solve problems that seemed impossible. The investment produced radar systems that changed warfare fundamentally, created capabilities that enemies could not match because they lacked the industrial capacity and scientific infrastructure to compete. The AN/APS-6 radar that terrified Japanese pilots was merely one product of that investment. A small portable system derived from research that produced shipboard search radars, fire control systems, navigation aids, ground control intercept networks, an entire constellation of technologies that gave American forces information superiority in every environment. Japanese generals and naval commanders, reviewing intelligence reports after the war, acknowledged the shock of discovering American radar capabilities exceeded their most pessimistic assessments. They had known the Americans possessed radar. They had not comprehended the sophistication of systems being fielded, or the operational advantages those systems provided. Japanese radar development had focused primarily on ship detection, air-to-surface vessel systems that submarines used to locate convoys. Airborne interception radar remained experimental because the technology required miniaturization that Japanese electronics industry could not achieve with available materials and manufacturing techniques. The few prototypes that reached testing phase were too heavy, too unreliable, too primitive to provide operational capability. Japanese night fighters continued, relying on visual detection while American radar-equipped aircraft dominated. Nocturnal skies through technological superiority that widened every month. The darkness itself became weapon, but only for forces that could eliminate darkness through technology. Japanese bomber crews approached targets in conditions they believed provided concealment. American radar illuminated those aircraft miles before visual detection was possible, provided tracking information that allowed night fighters to position themselves perfectly, guided interceptors through clouds and rain and moonless nights with precision that shocked Japanese survivors. The experience of being attacked by an unseen enemy, hit by tracers emerging from total darkness, knowing the American pilot could see you when you were blind, created psychological pressure that no training could overcome. Japanese bomber formations would dissolve after first contact, aircraft scattering and fleeing rather than pressing attacks, because continuing toward targets required flying through darkness that no longer provided protection. The transformation was complete by 1945. American night fighters controlled the nocturnal sky as absolutely as daylight fighters controlled afternoon. Japanese night operations that had been routine in 1942 became near suicidal by 1945. Aircraft venturing into darkness where radar-equipped fighters waited, where ground control networks tracked every movement, where interception was near certain regardless of weather or visibility. The cost in Japanese aircraft and crews was unsustainable. The psychological impact on surviving pilots was devastating. The strategic effect was decisive. American forces no longer feared night raids. Japanese forces no longer mounted them except in desperation. The radar pod remained the enduring symbol. Small bulge under the wing of a Hellcat, equipment housing that weighed less than most bombs, component that represented American technological supremacy and industrial capacity beyond Japanese capability to match. The pod housed electronics that could see through darkness, track aircraft through any conditions, guide fighters to targets invisible to human eyes. Inside were cavity magnetrons that generated microwave pulses, receivers that detected echoes too faint for human senses, displays that presented information processed thousands of times per second. The complete system worked because American industry could manufacture precision electronics in quantity, because American scientists understood microwave physics well enough to miniaturize complex systems, because American resources permitted development programs that cost more than some nations' entire military budgets. The Japanese captains were terrified not of darkness itself but of American technology that eliminated darkness as protection. They flew into nights illuminated by radar, tracked by systems they could not detect, hunted by aircraft guided with electronic precision. The terror was rational recognition that they faced enemies who possessed capabilities beyond their technology to counter. The darkness that had been their ally, the concealment that had made night operations viable, was irrelevant against American radar. They could train for darkness. They could not train for detection systems that made darkness meaningless. They could develop night fighting skills through years of practice. They could not develop radar systems through training when industrial capacity and scientific expertise did not exist to build the technology. The night belonged to America because America had built technology to own it. The radar pod represented that ownership. small component housing electronics that detected Japanese aircraft when they believed they were invisible, guided American fighters to optimal attack positions, coordinated intercepts through ground control networks that tracked entire airspace continuously. The Japanese saw the pod and understood they faced systematic technological disadvantage that courage could not overcome. The Americans saw the pod and recognized it as a symbol of industrial mobilization that had transformed scientific research into operational capability in less than 3 years, created night fighting systems more capable than Japanese could imagine when American development programs began. The lesson of radar-guided night fighters extended beyond tactical advantage to fundamental truths about industrial warfare. Technology properly developed and fielded at scale could create capabilities that traditional military virtues could not match. Resources invested in research produced results that training and discipline could not replicate. American willingness to fund unlimited development, to coordinate across military services and civilian institutions, to manufacture precision electronics in quantities that exceeded all previous production, created advantages that Japanese industry working under severe material constraints could never overcome. The darkness became battlefield where these advantages were most obvious, where electronic vision illuminated what human eyes could not see, where American fighters hunted with confidence born from technological superiority that radar provided. The terror Japanese captains experienced when radar-guided American fighters appeared from total darkness was recognition that night no longer belonged to those who trained to use it. Night belonged to those who built machines to eliminate it, who developed radar systems that detected aircraft through any conditions, who fielded night fighters in numbers that ensured interception of any raid. The psychological reversal was complete. Japanese pilots who had operated with relative impunity in 1942 flew with dread in 1945, knowing that darkness that had protected them now concealed American fighters tracking their every movement on radar, preparing attacks from optimal angles, waiting for perfect range before firing. The night had become enemy territory, contested airspace where technological disadvantage meant near certain death for pilots brave enough to venture into darkness that American radar had transformed into killing field. The radar pod, that small bulge under the Hellcat's wing, represented industrial and scientific mobilization beyond Japanese capacity to duplicate. It symbolized American willingness to invest enormous resources in solving problems that seemed impossible. Coordination between institutions that shared information freely, manufacturing capability that produced precision electronics while simultaneously building ships and aircraft and weapons in quantities that overwhelmed Axis production. The pod was physical manifestation of systemic advantages that determined the war's outcome as surely as any battle. Proof that technological superiority properly developed and fielded could create capabilities that training and courage could not match. The Japanese captains were terrified because they understood this truth, recognized that radar made their night fighting skills obsolete, that American technology had eliminated advantages they had relied upon throughout the war. The darkness remained absolute and impenetrable to human vision. But American radar saw through it clearly. Electronic eyes that detected aircraft miles away, tracked their movements precisely, guided interceptors with mathematical accuracy. The terror was knowing you were being hunted in conditions where you were blind, and the hunter could see perfectly. Being tracked by systems you could not detect, targeted by aircraft positioned invisibly in darkness you had thought was sanctuary. Japanese bomber crews flew into that terror nightly, until their commanders finally acknowledged the futility of night operations against radar-equipped forces. The raid ceased. The night belonged entirely to America. Contested airspace won not through combat, alone but through technological advantage, so overwhelming it made conventional resistance pointless. The AN/APS-6 radar and the night fighters that carried it represented American innovation, transformed into operational capability through industrial mobilization that Japanese could not match. The terror Japanese captains experienced was rational fear of technological disadvantage that training could not overcome, acknowledgement that darkness no longer protected them, recognition that American radar had transformed night from sanctuary into hunting ground, where electronic vision dominated absolutely.